In this video, we're going to talk about an application of the discounted cash flow techniques, which is capital budgeting. In essence, capital budgeting is all about choosing projects for a corporation. We want to do a project. We need to find out whether or not that project is economically feasible. How do we do that? We have to predict some cash flows. We'll talk about that in some later videos. But in essence, we have to apply some techniques that will help us assess whether or not a project meets our minimal requirements to be considered a good project. So here we have a project that has some cash flows. We're going to spend $700,000 for the project. These are the cash flows that we expect to receive. Now, one way we can do this is through a worksheet that's called the mixed cash flow worksheet for time value. Now, you could do this by hand, but you would have to calculate the present value of every cash flow, and that obviously would take some time. So, using a spreadsheet, it's much easier to do those calculations. So, if you look at the formulas, right? The first formula that we have an interest in is the present value of the cash flows. This is the benefit. Some people refer to it as merit. That's a little bit stretching it, I think, as far as the English is concerned. But essentially, this tells us what the project is worth. The net present value, if you note, you take the net present value and you subtract the investment. This tells us whether or not the project will add value or detract value. We'll talk later about internal rate of return. That here is the actual rate of return on this investment. And another thing that we can get from this is we can actually ask questions about reinvesting our money, right? We're going to invest money today, and that's going to bring us money in the future. What are we going to do with this money that we get in the future? If we can reinvest it, how will that grow throughout the project? So here is the problem-solving part of this question, right? So the value of this project, it is worth $799,000. Now remember, at time zero, the investment needs to be input as a negative amount. That makes some of the formulas a little bit tougher, but we need to tell the computer that it's negative. And this, again, is important for some of the techniques and the formulas, especially in Excel. So the net present value then is that 799,000 minus that 700,000. So the value is $99,000. Internal rate of return is 17%. Now, if you look at the future value, if we reinvested all of these cash flows at the end of year 10, we would have $2.9 million if we could earn 14% on this investment. So the first technique that I'd mention there is net present value. It's just the present value of those future cash flows minus the initial investment. What it measures, though, is the important part, right? It measures the amount of value creation. In other words, it measures shareholder wealth or corporate wealth increases or changes in wealth. So the decision rule says if you accept the projects, if the net present value is greater than zero, that means you're adding value. You reject projects if they're less than zero because they would be detracting from value. Now, what you might notice is missing here is the equal sign. I'll talk about that a little bit later, but just remember for taking a quiz or maybe in the homework, if it asks you a specific kind of question, the equal sign is not part of the decision-making process. It's either greater than 0 or less than 0. If we switch to what's referred to as the capital budgeting techniques worksheet, again, I've changed the problem here. We spend $40. We started this in another video. You get $7.50. These are in millions for the first 9 years. And in the 10th year, you get $17. The discount rate's 10%. The net present value, if you look down below, is 9.75. So that's $9,750,000 is the net present value. Again, that represents the increase in wealth for shareholders, an increase in value of the corporation. Looking back at some other techniques we talked about earlier, the payback methods, 5.33 is the payback method for this ratio, for this project, and 8.0 is the discounted payback answer. We can show here, this is where we show how the payback period works. And this is, you have to do a little work for this, right? So what this does, here are our cash flows. And we start subtracting the cash flows, or in this case, adding the cash flows back to 40. So $40 minus that $7.50 means we still have $32.50 to recover. You subtract another $7.50, we're at $25. So this cumulative difference continues to subtract the cash flows from the remaining investment. Sooner or later, it changes sign. So how do you get this answer, 5.33? So when did it change sign? Right here, at the end of year 5, it changes sign. So you used 5 years of cash flows, plus you're going to use part of year 6. So all you do, ignore the sign here, all you do is divide these, the cash flow, this cash flow, 2,500, you divide that by next year's cash flow. So 2,500 divided by 2.5 divided by 7.5 is a third. So that's 5.33. As we discussed earlier, the discounted cash flow, you just convert the cash flows to present values, do the same process. So here, it turns negative right here at year 7. But if you also note here, the next one, it's negative. So it's negative 0.01. So essentially, we're going to use all of these cash flows in order to recover the entire investment. So the answer is 8.0 is the discounted cash flow, payback period. Another technique we have is something called the benefit cost ratio. It is also referred to more often as what's referred to as the profitability index. You take the value or the benefit, the increase in wealth, right, of the project, and you divide it by what that project costs. So 49.75 divided by 40, it's 1.24. Again, you accept projects where the benefit, right, the present value of the cash inflows, is greater than the cost. This is a strict cost-benefit ratio analysis. Greater than 1, you accept. Less than 1, you reject. So if we look back here to our example, here we find our answer. The profitability index is 1.24. The next ratio to talk about then is the internal rate of return. Now this is the discount rate that makes the present value of the stream of cash flows equal to zero. I will tell you, that's the definition, but it really doesn't describe what we want to know, right? The internal rate of return is the rate of return associated with the cash flows, assuming they actually occurred. What makes this difficult is that most of the cash flows are going to be uneven. So the decision rule says you accept the IRR if it's greater than the cost of financing or the cost of capital. And of course, you reject the project if it is less than that. And I think this makes some sense, right? If you think you're going to earn 12% from a project and it only costs you 10% to buy it, then you would want to do that project. So again, if we look back to our example, 14.993, essentially 15%, and that is definitely greater than 10%. So we would say from the internal rate of return that this is a good project to do. Now, graphically speaking, if you were to go back to this example and change this discount rate, what if the discount rate was 1%? What would be the value of the project, or the net present value, if the discount rate were 1%? Calculate that net present value. Then do it for 2, 3, 4, 5, 6, etc. So now you're going to have a string of net present values that we would like to graph. Excel does this very nicely in something called a data table. And the data table is available on that capital budgeting technique worksheet provided to the class. So what we see here is this is the graph. This is the line. Again, we know the definition says the internal rate of return is where the net present value equals zero. So it's right around here, around 15%. A couple of things to understand. So we kind of pulled together the discounted cash flow method. If the discount rate is decreasing, right? It's decreasing. What that essentially is telling us is the cost of financing is going down. What could cause that? One of the things that could cause decreasing costs of financing is the company doing better, maybe becoming less risky. So now banks and investors are charging less to give us money. What happens? If you can decrease the risk of the company, decrease the cost of financing, not just the value of this project, but the value of all of your assets will go up. So again, you could try this. Again, I suggest you pause the video and review this answer and see if you can come up with the answer. Again, down below, again, if you're using Excel, you can provide the answers or in the notes of this PowerPoint presentation. We can apply these discount cash value applications to a bond. So there's one of the examples. We can use the time value of money, and this is what we know about a bond. Par value is 1,000. So at the end of the time frame, you're going to get $1,000. So the future value is $1,000. The coupon rate is 8%. So if you put 8% times 1,000, that means you're going to receive $80 a year for 9 years. So you get $80 down here. It's 9 years. The required return is 7%. So the value of this bond is negative $1,065 and some pennies. And of course, you can do this also with Excel, just straight the formula for Excel. If I told you, though, that the bond paid interest semi-annually, The two things you would need to change if you're using the time value worksheet, you need to change the payment from 80 to 40 because you're going to get that in 2 payments. And you also would have to change the compounding frequency from 1 to 2. If you're using the Excel formula, remember the rate is the rate per period. So it would be 7% divided by 2. Number of periods would be 9 times 2. The payment would be 40. And of course, the future value, 1,000. And of course, you'll get a slightly different answer because of the compounding frequency. And again, you can try this with Excel and calculate. We have a bond for $1,000, matures in 9 years, has a coupon rate of 4.95%, annual coupon payments, and you're given a discount rate of 4%. So what is that bond worth? We have one more example that we can talk about with respect to a type of an investment. This is what's referred to as a perpetuity. And a perpetuity, if you want to find so what is the definition of a perpetuity? It's a equal payment stream, but the payment stream has an infinite life. Because of that infinite life, we can simplify the formulas so that we end up, if you want to find the value of a perpetuity, P here, is the payment divided by the interest rate per year. So if you wanted to receive $10,000 a year forever, and you could earn 10%, 10,000 divided by 0.1 says that the value, that thing would have a value of $100,000. If you knew the price and the cash flow, of course, you could solve for the rate of return. Again, this is just a special kind of an application for a discounted cash flow problem. I look forward to seeing you in the next video.